discoveries, the Vedic calendar 360 days, 12 times 30, but averages to 365 over 6 years because of correction month. Jyotisha Vedanga records astronomical data 4000 BCE. Excuse me, Sage Yajnavalkya 3000 BCE propounded heliocentric model. Shatapatha Brahmana he measured the distance from Earth to Sun, Earth to Moon at 108 times the diameter of the Earth and Sun and Earth. Modern figures are these. Surya Siddhanta has got a lot of complex astronomical and time measurements. 2000 years ago, Indians proposed stars were like the sun but further away. Aryabhatta had something that looked like a partial heliocentric model. He knew that the shadows of the earth, shadows of the moon because of the sun shining on it. He also had formulas to compute the length of the shadows and if an eclipse will happen and all those kind of things. Varahamihira said same force that holds objects to earth also holds celestial bodies in space. Brahmagupta calculated Earth's circumference at 36,000 kilometers. Bhaskara too calculated precision of equinox at 25,461 years. The same precision that I'm talking about, Bhaskara too put it down to 25,441 years. Very, very accurate figure that was not bettered upon until European science around 19th century. Sayana, who was a minister in the prime minister in Vijayanagar, he, in his commentary on Rig Veda, computed the speed of light. Subhash Kak shows that his 2202 yojanas and half nimisha translates to this figure, very modern figure. Surya Siddhanta, amazing book. You can download this from Google and read it. It contains chapters on astronomy, time cycles, and planetary diameters. Yep, you heard me right. It talks about planetary diameters. Not only were the ancient Indians observing these planets as blobs of light moving in the sky, but they also knew those blobs of light have got a diameter, a physical dimension associated with it, and they were able to compute it. So Surya Siddhanta lists Mercury at not in miles, obviously, these are modern interpretations. 3008 miles, the true figure is so much. Saturn at 73,000 miles, this is the true figure. Mars at 3,700 miles, this is the true figure. Venus and Jupiter, they made some mistakes in getting those things. Now, you may wonder how on earth did they do that? Whether it was 700 BCE or 480 current era, how on earth did they do that? They didn't have telescopes. How did they do that? Well, it turns out that they used trigonometric ideas. One idea, if you have the half moon directly overhead of you, you know that the illuminated face of the moon comes 180 degrees away from the sun. You know that if this distance from you to the moon is 1, if this angle is 1/7 of a degree, then this is 400, a right angle triangle property. Using these ideas and using ideas that everybody who's done integration in high school knows about, if you did Riemann integration, you know that you had to draw a lot of lines over there in your graph paper and summing the area under the curve. You know, those lines help you to do that to get a better and better figure. Similarly, the ancient Indians, in order to compute Tithi, they needed to compute Tithi, when a particular Tithi would pass and so on, as accurately as possible. So they would divide the nakshatra from one to the other by finer lines of resolution, which will allow them to map the movement of heavenly bodies in a much finer way. So by making use of how quickly the bodies are moving and by using trigonometric ideas, they were able to estimate these planetary diameters. That is the ingenuity of our ancestors that we need to connect to. This is lost in the popular discourse completely. We have no idea. We don't even talk about these things.